Hello again, this is Professor Jim Caffey, and today we are going to do Chapter 23 out of the OpenStax Astronomy free textbook. Chapter 23 is on something really neat, the death of stars. Let's go! We talk about stars living a life, just in the same way we would say human life. A star is born, it grows up, becomes an adult star, lives a long life, and then somehow dies. Chandrasekhar here did a lot of the work on stellar corpses and white dwarfs, which are dead stars. Let's get through some of this. Here is the structure of an old massive star. So we have talked before about these shells inside the star, and you go from hydrogen to helium to carbon, oxygen, neon, silicon, and then iron. And at the end, iron does not fuse and the star explodes into a supernova. Here are some supernovae in other galaxies, and you can see the galaxy being so far away, billions of light years, but yet we see one single star lighting up brighter than the entire galaxy. Here is some more remnants of a star that has exploded. Another supernova remnant from the year 1006. Another supernova seen by the Hubble team. Again, it outshines that whole galaxy. In 1987, a different kind of star exploded in the Large Magellanic Cloud in the southern hemisphere. And here we see a composite of many images of this remnant. A very unique star to study. There is a ring around this supernova that went off in 1987 in the southern hemisphere. Now, over time, a supernova will decrease in its brightness, and certain supernovas will allow us to get distances to those other galaxies, and we call those kinds of stars standard candles. The Crab Nebula is 6,500 light years away, and in the middle is actually something different. It is a neutron star, about 6 miles across, the size of a small city, and it's just neutrons, super compressed in that core. And if that neutron is spinning, and then we can see pulsations, then we call it a pulsar. Just like a lighthouse has a rotating beacon, those pulsars do the same. And here is a model of a pulsar. Very, very large magnetic field around it, spinning incredibly fast, maybe once a second or faster. And this beam of energy shoots out, and if it's just in our line of sight, then we can detect it. Here we have the evolution of a binary system, what I study the most. We have two stars that live and die, a red giant, a main sequence star. The red giant becomes a white dwarf, and that red giant starts to suck energy and matter onto it, and it explodes. A gamma ray burst comes from the very edge of the universe, and we can see those again in these images. In 2008, this gamma ray burst was observed by our Swift Observatory in X-rays. Some of these bursts are beamed out. We call these gamma ray bursts, or GRB. Here is an artist's illustration of our Swift X-ray spacecraft. And that's going to do it for Chapter 23. Thank you for joining me, as always. I'm Professor Jim Caff.